point out, it was interesting. The one example, if you can just put that in presentation mode, Aiden.
Yeah.
The one interesting example that I know happened firsthand with Fortinet, this is one of the first time one of his colleagues spoke, and you could watch some of the videos on our website, was the ease of Fortinet getting deployed in an environment that used some other equipment. And that, I think will come out during Aiden's presentation, is the great technology behind the Fortinet security solutions. And I'll look forward to hearing from this. And we hope he attends a lot, and maybe he'll be able to take me to a golf tournament sometime in the future.
All right,
all yours,
we throw some pretty good golf tournaments. All right, so the first thing I'll tell you is that I won't be able to do justice in terms of the depth that would serve you well. So, what I'll do is I'll get into some of the well-architected security principles, talk about what we do at Fortinet. I can, if there's time, get into a little bit of a demo just to show the simplicity from a SaaS delivery perspective. So I appreciate the time. My name's Aiden Walden. I'm the global director for our architecture and engineering for cloud practice. So I just deal with cloud here at Fortinet. So what I want to talk about are, the customer's view on the hybrid cloud challenge. Everything that we do at Fortinet is really driven by customer interests and customer use cases. From there, we derive the principles of a well-architected security framework, things that are important to accomplish when you're building out your security architectures. Those use cases, specifically in the NGFW network security perspective, those specific use cases, we'll dive into them in a little more detail, and then show how we can drive automation, which is very important for being able to function operationally and derive operational efficiency and achieve the type of agility that, as a security practice, you'll want to achieve in cloud. And then network security as a service. So, there's a contrast between how security is delivered as an infrastructure as a service and then as a SaaS. But a little bit about Fortinet. We are closing in on 650,000 customers globally. We have more security endpoints deployed than any of our competitors, actually several times our competitors. So we have a very large global footprint. From there, we derive massive amounts of global threat intelligence, which really is the value behind what Fortinet can do. We're a big player in most enterprise networks, going through the top 2,000. So the reality is that hybrid networking will always be with us, even if you are a pure play cloud organization, or you were born in the cloud, so to speak. If you have users, you're going to need to access those cloud services from outside of the cloud. So in that sense, everything is hybrid. And at Fortinet, we're very focused on delivering a journey for our customers that allows them to operate in cloud as securely as they do anywhere else. So what does the entire IT estate look like from end to end? And how, with best practices, do you secure that entire IT estate? And we really are focused on what customers are asking asking from us is delivering on a consistent, ubiquitous cybersecurity platform. Now, that doesn't necessarily mean that it's one vendor, right? It's about allowing the customer to define the ecosystem, embracing the ecosystem and the partners that the customer wants to use, and making those systems work very well together to derive the greatest efficacy out of the cyber infrastructure. So in many cases, we are working with direct competitors to better our customers' outcomes. And the diversity of devices connecting into the IT estate, into the cloud environment, it was mentioned earlier by AWS, the AWS outposts, and where outposts are deployed. A lot of those are deployed in manufacturing environments. There are a lot of headless sensors being connected, IoT devices in addition to OT devices. And so that is a big area of concern and drives a lot of the connectivity into the hybrid cloud space. So the thing that we see and a lot of what we're focused on strategically is the consolidation of security functions. There was a time when you bought security completely separate from the networking stack. Now those are highly converged. And these use cases are the use cases that are really driving the convergence. And this is, the same whether you're in the data center, you're dealing with remote branches or users, or in the cloud. The firewall it's the core control point in the security infrastructure. It interconnects and manages the overall security posture and provides a lot of the visibility into what's happening in the at the network layer. We also can provide application security as well. And that's networking has collapsed into the firewall function. So SD-WAN, software-defined WAN services, whether you're typically going into the cloud as a cloud on-ramp, or in some cases, egressing from the cloud. Maybe you have multiple egress technologies from the cloud, such as a express route and VPN, or direct connects and VPN, something like that. And we see use cases where the cloud environment is actually an SD-WAN source. And then the branches themselves are software defined. So everything is controlled via the central infrastructure, whether it's the LAN switching, the core switching, the firewalls, the network, all of that is coordinated as a single function with security defined across that entire physical or virtual infrastructure. And SASE really encompasses and brings all of those aspects together and allows for a different mode of consumption, a SaaS-based consumption where secure access such as ZTNA can be applied. And so we're really focused on these principles and the consolidation of these, the convergence of the security and network domains. Now, if you're a customer, you have a lot of operational considerations. Firstly, you have distributed applications that may be resident in multiple cloud environments in the data center. And you have users who are accessing said applications from anywhere and from different devices, right? So we have to consider all of the security principles in terms of identifying the devices, controlling the networks, limiting access on those networks. But then, at the same time, those logistics are being managed. You're dealing with a much more capable adversary. There's a much larger attack surface, primarily because there are more applications and more APIs being exposed. We spent a lot of time talking about API security. The supply chain is also part of the consideration. And then social engineering. Humans will always be probably the weakest link in the security apparatus. And how do we provide visibility and control and least privilege to those users is always an important concept to any security approach. Okay, principles that guide us. So working with the thousands of customers that we get the opportunity to serve, these are the things that are time and again the principles that we focus on. We want to drive policy consistency across the hybrid environment. And some of this actually, as listening to the AWS portion and some of the other cohort on this call, a lot of these things are repeated, which is a good thing. I think we're all saying the same thing here. But whether or not you have infrastructure in the data center, on a person's personal device in the cloud. And by the way, personal devices is interesting because it could be a managed or unmanaged device. We have to be able to deploy policy in a consistent way across all of those environments. And that's where we get into a challenge of, okay, you want a certain level of cloud nativeness, but you have to also transcend any particular one platform. And so there's a certain amount of abstraction that happens there. Segmentation is as important as ever. As the cloud networking constructs have gotten more mature, things like transient gateways and virtual WAN hubs and network connectivity centers and so forth provide the opportunity to scale networks in larger ways. You also have to provide control between these network segments to make sure that there's limited access. And then having service context, right? So once I've deployed policy, right, that can become very cumbersome. And so I need the system itself to have awareness of what applications are running, what protocols are running, how users are accessing those applications in a dynamic way. And service context is about using the software-defined facilities such as metadata and data classification and tagging and all of that to automate and drive policy that's near zero touch. So if I have a certain business intent that I expect from a policy, and somebody spins up a new workload, or I have ephemeral workloads that are scaling in my environment, the security system should be able to pick that up automatically, make a determination about how a policy should be applied, and then provide limited access based on the needs of the application at any given time. That's service context. Quality of experience. I think this gets lost. We're very much with cloud, and as cloud moves into the edge, it becomes a little bit more fuzzy. But the goal will always be to provide a quality experience, and security can't be a gate necessarily to the experience. And so whether it's real-time video or it's an ERP database that is highly performing, we can't be an imposition on those services and that experience. And so, the challenge is, how do we deliver security in a way that also provides great experiences for those applications? That goes back to that service context. If I'm aware of the type of application that I'm running, then I can provide that better experience. Deep inspection. This may seem pretty basic when you're talking about network security and NGFW capabilities, but not all deep inspection is the same. Being able to unpack protocols that are on non-standard ports, being able to provide man-in-the-middle services, and encryption and decryption at highly performing rates at scale is a challenge in the cloud. And so I want to maintain end-to-end encryption, but I need to do inspection because most malware, most traffic is encrypted now. So if I'm not doing deep inspection on that, then I'm probably not secure. And then performance, right? So this is your scale up versus scale out, and understanding the particular use cases. I'll touch on a quick example of how we uniquely do that. Now, our goal at Fortinet is to secure your application wherever it may exist, secure your users and however they may access your networks. And so there are a number of high-level use cases that bring the overall network together, whether it's on a public cloud, in a data center. We really view what the takeaway is from this image is that all of the cloud environments and all of the private facilities are really edges that are converging, right? And they are very dynamic. And so they're not always static. Applications don't exist in one place forever, and they scale differently. And so what we want to do is be able to, as I've mentioned before, in terms of policy consistency, start to apply these best practices across this entire footprint, so that I have a single policy context that is aware that I have SaaS applications that can filter maybe based on the tenant that is being accessed. Maybe I have a public Google account, or excuse me, a work Google account versus a private Google account, and I want to be able to access only the work Google account and block the private, as an example. Or I need to make sure my ERP system is not exposed on a public interface such as SAP, and do all of these things without people having to manually define policy across this entire state. So this is where we're coming from. Okay, some of the use cases, so we're going to focus on network operations use cases. The core, if you're familiar with Fortinet, and I'll tell you if you're not familiar with Fortinet, our marquee solution is our FortiGate virtual firewall, or a next generation firewall. Regardless of where you happen to run a FortiGate, you're going to get the same experience. And when I say regardless of how you run that, it could be a virtual appliance, it could be a physical appliance, it could be the SaaS instance with our FortiGate CNF. You will have a consistent user experience. This allows you to, one, scale policy, and also scale your skill sets across all of your environments, because they can be managed from the same pane of glass. So 3 use cases: security into the cloud. Think of cloud on-ramp, connecting remote sites to access those cloud services. SD-WAN has matured at about the same rate as cloud has matured, because the #1 use case for SD-WAN is to access cloud services. And security across clouds. And this is very much the hybrid model. During COVID, that's the only time I'll mention COVID, but we saw a lot of remote desktop services, workspace and so forth, VDI services being deployed. But they had access to applications that were resident in other clouds or other regions, right? And so now we have the cloud environments themselves as directly peering, and then as backbones, really backbone as a service, if you will, to facilitate or expand the IT network. That could also include co-locations. And then security within the cloud. So this is the segmentation component that I mentioned earlier, which is extremely critical. High level of view, where we're applying security is typically within a region. We're applying segmentation. This could be any of the public clouds, right? It doesn't really matter. We approach them in the same way. The firewall, the FortiGate virtual machine is aware of the fact that it happens to be running in one of these clouds. It accommodates that cloud. It connects to the underlying SDN, and it starts to pull information about these virtual networks or VPCs, whatever your preference. And that's typically, we're doing that on a per region basis, right? We don't want to traffic data across regions for inspection. And we're typically applying inspection closest to the workload. So think of, in a hybrid cloud environment where you have some data applications or services in the data center, or you have a branch location, and then you have cloud services. Well, maybe for egress from the cloud, you have an instance, say FortiGate firewall running in that environment, and then in the remote branch close to that user for their access going northbound, you also have a FortiGate. They're scaled accordingly, right? So we have cost controls, and Fortinet has a number of licensing options that provide scale across these different environments for cost management. But we're typically applying these services. So when you look at a pure play security provider, right, these are really the more advanced features that are derived from our global threat intelligence. Application control is a big part of this. Application control is what, upon deep packet inspection, SSL inspection, we are looking at the application itself. We're understanding not based on the port or the particular protocol. We're looking at the packet stream to see if there's malicious activity or content within that stream. And we can get very, very detailed there. So for example, I'll give you a really good enterprise example is, I can peel apart SAP RFC detail, and I can tell you, like the types of transactions as an example that you'll run in an ERP environment. So it gets very, very low level. And then we're applying these other threat detection capabilities on top of that. Typically, the services are run in a highly available mode. So this would all be diagrammatically an infrastructure as a service model. So the key points here, we've got segmentation. The workloads themselves have metadata values. So these firewalls that are applying these policies understand what applications are running. And so we can provide the appropriate north, south, east, west inspection with minimum access, just tailored to what that application and that traffic type and that workload happen to need. When we're moving across clouds, this is where centralized orchestration comes into play. Within Fortinet's portfolio, we have what's called a fabric management center. This includes a management plane to manage your policies across all of your IT estate, right? So I can apply policy here, here, here. It doesn't matter that it's one cloud versus another cloud, or it could be on a private infrastructure environment or be hardware. It doesn't matter. So from here, all of my analytics are being aggregated into this fabric management center. All of my policy is being orchestrated. All of my networking services. So think of, I want to deploy BGP across all of these environments to interconnect these in a very, very low effort way. There's automation that understands where these security appliances are deployed. understands that I want to apply an SD-WAN profile, maybe from these remote sites, and I want to build out a VPN overlay, and just a few simple clicks, literally, I can build out all of that environment. So that's where we're really supporting an automated, very fast deployment for these very complex environments. We want to take the complexity out of the management of the infrastructure. And this is a financial services example. So this happens to be on AWS. This is an actual customer deployment. So this is what a typical use case would be. So I showed you some high-level generic stuff. I wanted to show something a little more detailed in what we actually deploy with a customer. And so they have a data center with a highly available pair of FortiGates. These are, I believe, for physical appliances. And they have direct connect going into AWS at 100 gigs. But they also had to back that up, right? So we have a couple of different use cases that we're spanning here. They have a transit gateway to manage segments across large numbers, hundreds, if not thousands of VPCs. And we use multiple route tables to segment there. And then we broke out the use cases. VPN use case requires a deterministic termination point. And we wanted to scale this for encrypt and decrypt, right? So we did that. And then we broke out other inspections for, internet gateway access, egress, and ingress directly into that cloud environment. And we can drop an auto scale cluster here as an example, or actually up here, and then maybe a statically scaled cluster for east-west. And so by breaking out these use cases, we're scaling for very large environments in the most efficient way possible based on the type of traffic and the directionality of the traffic in this case. So if you have a need to design an architecture and you would like to talk with somebody who's done this a lot, my team is ready and willing to help you guys. Okay, so I wanted to give you a detail about really the performance side. And this is where Fortinet is really has some differentiation. We have a service called IPsec aggregation, and what we're doing here is scaling up enterprise connectivity from the data center in this example, or from a branch into the cloud. Typically, you'll hit the limits of like 1.5 gigs or 3 gigs on a first-party VPN service in the cloud. And what you also run into is scaling limits, because a typical IPsec session is tied to a single CPU core. So what you end up doing is buying a virtual machine, or you buy compute that you can't really optimize. And so we found a way to optimize that. And so what we do is basically are scaling up IPsec services, so we can hit very high bandwidths, 20 gigs. 10 gigs is typically kind of the minimum threshold for enterprise backup connectivity to a dedicated circuit. But the nice thing is I can deploy this from FortiGate to FortiGate, and I don't need to use complex routing aggregation like ECMP or VXLAN and so forth. So we're delivering very, very scaled up performance, enterprise grade performance that's cost optimized, because I'm getting all of the value out of my infrastructure and the CPU that I apply there. Here's what it looks like as an example. So we just deploy basically multiple phase 1 tunnels. Those phase 1 tunnels are bundled, and the software understands that these phase 1s are tied as an aggregate, and we can change the distribution model of packets across those tunnels. And then at either endpoint, those packets are reordered and delivered or decrypted across multiple CPUs to the endpoint. That's the summary. But there's, we could always go into more detail. I talked about metadata driven policy, and this is very important, because we don't want to be in the process of moves, adds, changes, and so forth. And so when you build policies within our platform, we're pulling out the tag data, classification data that says, okay, maybe I have a dynamic address group, and that dynamic address group applies to anything that has a particular tag or is of a particular instance type, and we resolve those to the IP addresses in the public cloud environment. So we know what the hosts are. And then once we know what those hosts are, and as they change, they're very ephemeral, they come and go. The policy is just a framework more than anything, and it picks up those workloads and applies the appropriate policy to those particular workloads. So in this screenshot, I have I have something tagged as tier 2, and it's also tagged as an environment for production. And so if it matches those tag IDs, that workload will match to the policy, and then that policy will be applied. Very, very efficient. When you look at the cost of managing like just SOC and NOC functions, we're giving you back hundreds and hundreds of hours of work time. You're probably struggling for those resources anyway, but we give you back that time that you would have spent on manual interdiction.
Aiden,
Okay.
Aiden,
Yep. Am I running out of time?
Yeah, we're a little bit over, so I just want to make sure you can highlight some of these as we want to finish up with our Microsoft talk, but not shortchange some of this.
Yeah. Well, I was going to go through some automated workflows that are really impressive, but I'm going to skip that. Just tell you, we want to support the ecosystem that's important to you. We have what we call fabric-ready partners, hundreds of them. And so we are tied into public cloud platforms, third-party APIs across a number of ecosystem partners, even competitors, as I mentioned. And we are deriving and sharing threat intelligence across hundreds of sources. And so all of this comes as a part of what you get when you deploy the Fortinet security fabric. Is really a broader ecosystem and not vendor lock-in. We're also highly tied into the public clouds, which is very important. So we typically keep pace with public cloud services as features and functionality roll out. We want to make sure that we are supporting those in the way that our customers demand. So I'm going to skip this last part largely because of time. But everything that I just explained, if you want to manage all of that infrastructure on the security side, that's great. We also provide it as a service. So literally, the only thing that you would do in all of that infrastructure, whether it's auto scale clusters or VPN, well, not VPN, that's not included, but if you wanted to support ingress, egress, north south, east west, north south use cases at scale and on demand, we can provide all of that as a service. The only thing that you would do is simply point your traffic to our hosted 48 clusters. It's very, very simple. So everything is the only thing in your environment is an endpoint, which is basically a network interface that's tied into your route table, and you point the traffic to us, we inspect it. There's no need for IP address renumbering. You don't have to worry about, it's all completely transparent. So you don't have to worry about any changes in your environment. So it supports it's a very easy transition if you have either a legacy or greenfield environment. Okay, I'm going to skip to the end and thank you for your time and turn it over to Ron and Microsoft. Thank you.